Thank you all for having me. It's my first time in Poland and in Krakow and at App.js, so this is like 3 firsts for me in one go, which is more than I can handle with very minimal sleep, so we'll see how it goes. Very excited to be talking to you all about building complex UIs with a server-driven React Native app. Now, nowadays when you put the word server-driven, if my clicker works, there we go. Nowadays, when you put the words server-driven and React together, people automatically assume that that equals RSCs. And RSCs are a contentious topic at the best of times in the React community. If we draw out a Venn diagram of the entire React community, roughly speaking, it's kind of split up by this. Not that. There we go. It's kind of split up something like this. You've got people who are excited about RSCs. It's all they can think about. When they go to bed at night, they just stare up at the ceiling, and they're thinking about how RSCs can revolutionize apps. I'm seeing some nods there. Is that you, Evan? That's Evan, all right? We've got people who are sick and tired of hearing about RSCs, and they have developed a sort of inherent gag reflex to the word server and components. And then we've got React Native developers, most of us are just sort of somewhere in the middle. We're a little bit confused about what RSCs mean for us. And so these folks are here thinking this is an RSC talk. These folks have probably left now thinking this was an RSC talk, and most people are probably just confused. This is not an RSC talk, which effectively means that these folks are disappointed. These folks have left and hence will be disappointed when they figure out it's not an RSC talk. And the React Native devs are confused. What I'm trying to say is that I basically excel at disappointing. It's my one talent, and everyone keeps reminding me. Thank you. Great. OK, all of that aside, stupid intro. We're going to talk about server-driven UI, split up into how it works, when you should use it, and what some of the challenges are. We're going to go through a very basic example for how it works. Let's imagine we've got an e-commerce store app called React Clothes. And the layout is roughly as such. We've got a banner at the very top. Then we've got a section for offers. As we scroll down, we can see that past the offers, we have recommended products and then some featured categories. It's a very simple app, right? And if you look at the homepage component that we may have in this application, it may be as simple as having a banner, offers, recommended products, and the featured categories, just ordered in that sense and being rendered inside of the homepage. Let's just ignore the header and the tab bar for now. So one day a PM comes to you and says, we've actually run some tests. Can you swap the offers and the featured categories sections? So it's not really that much of a big deal. You just kind of go in, change the orders. It's probably the simplest ticket you've ever had to do in your life. And you change up the orders. And once you push that out to the users and it's been updated, the order in the actual screen will reflect those changes that you've made. All good. A few days pass. This PM comes back to you again and says, you know that banner that we've got at the top, it actually gets a bit annoying once users have seen it once. So maybe once they're logged in, we just remove that banner altogether. So a little bit more complicated, but not a big deal. You have a hook for getting the user, and you basically create a Boolean to say, should we display this banner? And then you conditionally render that banner. All right, not that much of a big deal. Again, you have to update this, go through an update process. Either that means an over-the-air update or doing a new build and submitting to the App Store. So there's going to be some time before this change is reflected for your users with every single iteration that you do. But it's not that big of a deal, so we'll keep going forward. Another week passes, and this lovely PM comes to you, and this time it's a little bit more complicated. They say, I want to be able to personalize the orders for every single customer, so basically it may be that all of these are going to be moved all around for every single per customer view, effectively. And so that's where your house of cards starts to fall apart. And you're kind of left feeling like this with the current architecture that you've got. Now, you may be contemplating going up into the mountains, becoming a sheep farmer, which I have done several times, and just giving up on this whole software gig. But what if I told you that there was actually a paradigm of architecture that you could use that could tackle all of these problems? And that is, drum roll, server-driven UI. Shocker, right? So the whole concept with server-driven UI is that you allow the server to define the layout of the screen. What that means is you create a layout component on your client. That receives some JSON that defines the order of the different components and all of the data that's within that component as props. And effectively, that will dictate how the screen should be rendered. So the JSON might look something like what we've got on the right-hand side. It defines a banner and any of the props and the data that the banner needs to render. It defines the offers and says what are the props for every single offer that you may have. Now, what this would look like in our code, and this is a very basic example, this isn't something that's production ready, but just to kind of get the fundamentals down, is that you would have a map from the components that are coming from the server, mapping to a specific component that's within your code base. So you would say, when the server gives me a string called banner, I'm talking about this specific banner component in my code base. Offers, this specific offers, so on and so forth. And then you create almost a dynamic rendering function where it can use that components map to take a config object that's coming from your server, whether that's a CMS or an API endpoint, and render the component passing through the props dynamically. And so your homepage component becomes this sort of more dynamic component where you fetch the JSON data using some sort of loader that you have, and then you map over the JSON data that's come back from the server, and you use that render component that we just defined to render dynamically. And so what that means is it's all dependent on the JSON data that's coming from the server, and it's all going to be dynamically done at runtime. So taking the JSON from the API and the CMS, pairing it with that homepage component, you get the layouted application in whatever format that's being returned by the server. And this comes in many different shapes and sizes. You don't need to do this for your entire app. You can do it for an entire screen, but you could also do it for sections of your application, or you could even do it in individual components, and we'll look at a few examples of individual components in a sec. Okay, all of that's good from a primitives perspective, but when should you use server-driven UI? And I think the best way to answer this is to look at some of the people that are using it out in the industry. So who's using server-driven UI? Well, first and foremost, Shopify is. We've got scratch that. There's Lyft. So we're going to take a look at Shopify and Lyft and see when and where do they use server-driven UI. So in Shopify's case, Shopify has an app called the Shop app, and it's basically a marketplace where different vendors can come in and list their items as a store on this Shop application, and it's sort of a centralized marketplace giving control to the vendors. And as they built this out, they basically had one layout for all of the different vendors, regardless of their size, if it's a vendor that's got hundreds of items or if they've just got a couple items. And they realized very quickly that's not scalable, it doesn't make much sense, and so they wanted a way to quickly and more flexibly be able to customize the layout depending on the type of vendor that they had, and hence they went for the server-driven UI approach. Business stakeholders also wanted to run A/B tests and personalization, and server-driven UI really shines here, and they wanted to increase the frequency of the releases. The other example was Lyft. So Lyft has an application where you can basically rent scooters or bikes for a short-term period. And so I think they started off with scooters, and then they wanted to extend out into bikes, and then docked bikes, which had different flows. So they actually decided to use server-driven UI just for a single piece of the component, which is that bottom sheet that you've got there. And it was going to have different layouts and different combinations of screens for different stages of the journey that you're going through when you're riding a scooter or a bike. So they basically use server-driven UI to add some level of flexibility there. And they wanted to do that only for features. So this is an example of where you have it for a single feature. They wanted to be able to update quickly and increase the developer's follow-up velocity, and that's one of the reasons they used it. So really, the common themes that I've seen, and we've built server-driven UIs for many reasons, but the common reasons are you've got complex layouts and variations. You want to increase your dev team's velocity. You want to add some level of user personalization. This is really where it becomes powerful. And you want to also have A/B testing being significantly easier. And maybe your requirements are changing very quickly and you're just iterating very quickly, so it makes a lot of sense. But really the meat of this talk for me is the challenges that come with server-driven UI, because it's not just a slam dunk. And the best way to describe it is through the law of conservation of energy. How many of you had this in school? This was something that we were taught in school. Raise of hands. Okay, so everyone. Okay, so it's not a curriculum thing. Energy cannot be created or destroyed, only converted from one form of energy to another. I like another variant of this, which is the law of conservation of complexity. And the idea is that complexity in an application cannot be reduced beyond a certain point. It can only be shifted from one part of the application to another. And I think that's just a really mature way of looking at software development. So I want to look at three main challenges: over-the-air updates, offline support, and performance. Let's start with over-the-air updates. Let's say I wanted to add a new testimonials component. I take the code in this, pass it to my lovely bundler, Metro, and then it generates a new bundle, and we push that to an over-the-air update server, probably Expo updates at this point. And so that server will basically push or make available the new bundle for different phones to access. Now, in some cases, they will successfully download the new bundle, and they'll have access to the new components that we've built, so they can actually take the JSON response that's coming from the server and render it correctly. But in some cases, it may just be that the network is not stable enough in terms of a connection, so it may not load on the first load, and it may be in the background, so that update will not take effect for the user. So they're still getting the JSON response from your API, but they're not actually able to render that component. Or, in the worst case scenario, what you may have is that you actually have certain users on an incorrect native version, so they can't even take the over-the-air update because it's not compatible with their native build that they've got. And so what that means is that there's always a delay for when the user gets your bundle, and that presents its own set of challenges when you've got a dynamic server-driven UI JSON endpoint that's basically dictating what the UI should look like. And the worst thing possible is to force users to update on every single sort of start of the application. It's really not a good UI. We don't like it as users, and we probably don't like it as developers either. So the two things you're going to need to keep in mind is you want to handle fallbacks and missing components on the client side gracefully. Sometimes that might mean actually just failing silently and just not rendering anything, but you just want to be actively thinking about this, architecting your app today, thinking about what you may introduce in the future, and making sure that it makes sense for what your roadmap is, so that if certain users don't have the latest version of the app still acts and behaves in an ideal way. The other thing that I've seen people do, which is a real challenge and is quite difficult to keep up and scale, is that they keep multiple versions of CMS and API responses for the different versions of the app. It's really difficult to keep that in like a practical sense because your CMS editors are just going to hate you for the rest of their lives. It's really not a great solution. So you're going to have to find some sort of balance and some sort of workflow that works. There's no good answer to this. Evan will probably say it's server components, but we'll leave that for tomorrow. But really, at the current state, there's not a good answer for this, and you're just going to need to take the hit, and this is one of the complexities that arises. Secondly, offline support. When you've got all of your UI being dictated by JSON that's coming from the server, then effectively to have offline support for your app to even run offline, you're going to need to have some mechanism of caching the JSON object to keep a store of what the UI would look like when the user's offline. The questions that arise, and there is no right answer again, is what do you cache? How much of that do you cache? Do you cache every single bit of that JSON blob, or is it just certain parts of it? How long do you keep that cache for, right? Do you want to just keep it indefinitely? But sometimes that might not make a lot of sense. So there's a lot of balance here that needs to come into play, and your mileage may vary depending on what you're trying to build. The other thing is this whole local first approach, right? There's certain cases where offline users might be able to make changes to the state of data that exists, and you want to be able to sync that back. So how do you do that in an effective way? You're going to need to have some sort of consolidation method there in place as well. And then you want to error handle for the cases where the cache is no longer available. So when you've got cache misses, how do you make sure that you still have a semi-usable app even if the user's offline? So again, more testing and edge cases, just things that you're going to need to keep in mind. You may have heard of Project Lightspeed. This is not a React Native specific example, but I think it's a really interesting approach of dealing with offline support for a server-driven UI app. So in 2020, the Messenger team rewrote a large portion of the Messenger app, and they called it Project Lightspeed because they basically were trying to speed up the startup time and just the performance of the Messenger app. And one of the ways that they did it was through server-driven UI, but the caching layer that they had was through a SQLite database that lived on device. So everything in terms of how the UI was being represented to the users was being dictated by SQLite, and that data, both from a layout perspective but also from a data perspective, was all being stored in a SQLite database, which I thought was a very neat approach and just goes to show that there's many different ways that you can deal with the caching issue depending on what your needs are, what your scale is, and what you're trying to achieve. And lastly, performance. So one of the challenges is there's a lot of JSON being passed around the internet. There's a lot of JSON that's being computed on some sort of backend server. And what you're going to need to know is that as you start using more and more server-driven UI in your applications, the JSON response payload size also increases, right? So as you add more and more, there's just sort of like a linear scale going up there. And the worst thing is to have the spinning beach ball of death where the users are just waiting a long time to even be able to interact with your app or see something to indicate that that things are running in a semi-correct manner. So could we do better? Well, let's start and see what the flow kind of looks like right now. If we have a basic server-driven UI app, we load the JS bundle on the client. We then make a request to the server, and the server starts fetching the right data to be able to create the big JSON blob that we've got. It may be making database calls, it may be fetching external resources, calling services, but that might be a lengthy process because it's basically trying to compute everything on the server. And then it creates a JSON response and sends that back to our client, and then we render that data. And so I'm going to use two web terms for performance here, but kind of loosely. They're not exactly right, but just bear with me here. FCP and TTI here. So FCP being the first contentful paint and TTI being the time to interactive. So the first contentful paint here is just going to be where the app kind of displays something semi-comprehensible for the user. So there's some actual content being shown to the user. And the TTI is when the user can start actually using the application. So if we look at the FCP and the TTI, and I've put FCP-ish because this isn't really FCP, it's kind of at the very end of the process. So it means all of that needs to occur before the user can actually start to use the app and they see something that's comprehensible and usable to them. If we tried to optimize this, though, what we could basically do is load the JS bundle, make a call, and get the basic layout from the server, just the layouting, nothing about the data that needs to be computed, and that's the expensive part to do. So getting all of the props and all of the data to render it fully is the expensive bit, but we're just going to get the layout JSON, and then we're going to pass that back to the client. And so the client can start rendering at least the basic layouting. And so we push the FCP significantly forward, so the app is visible in some capacity much sooner. And then it starts to make requests for each component to fetch the data. So the data is being computed on the server. And then once the data is available for each component, it basically comes in on demand for each of those components. And basically the TTI becomes whenever the last component finishes calculating the data on the server and returning that back to the client, and then the client renders that. So it means that we can pull both the FCP and the TTI forward significantly. So what that kind of looks like in a graph is that if we don't optimize, we have this kind of exponential growth for the first contentful paint-ish. And if we optimize, we'll have a constant growth because it's not really that expensive to calculate the layout. It's very basic. That data might be cached even, so it's just responding back to the API call that's being made. The TTI also is significantly improved because it kind of scales linearly with the time that it takes for the longest component to render, as opposed to adding all of those on top of one another. And what it would kind of look like is we take the JSON from the left-hand side. This was our initial JSON that has all of the data, and we just create a very basic, smaller JSON that just says these are the components that I need rendered. Now, when we look inside of the offers, basically that offers component will be responsible for querying and getting the data that it needs to render fully by itself. So that means that it's basically on the components themselves. It's the onus of the components themselves to get the data fetching for their own data. But could we do even better here? What if we kind of just did some of this rendering on the server? Like, what if we streamed some of it, right? Let's just take something from the React folks and see if we can bring it here. What if we loaded the JS bundle, and then we made a call, again, basic layout for the JSON, we get that back, we render it, fine. But in parallel, and that's where the FCP comes into play, but in parallel, we start to fetch the data, and we actually render those on the server. And then we send them back, and all we need to do is basically render on the client and hydrate, and that's pretty much it. That can also give us a significant improvement on the TTI. And what that would kind of look like is we'd wrap all of the different components in suspense boundaries, and then maybe we could just fetch the data for each of these components on the server. Maybe the secrets could just all live on the servers. You know, it's just a DB call directly there. Stop me if you've seen this before. So I lied. There is a little bit of RSC in this talk, and this is a bit awkward. You see, this is just a natural completion of where things need to go, right? You start from server-driven UI. This has been around for ages, but it all roads end here in the RSC world. It turns out RSCs and server-driven UI actually go really well hand in hand with one another. But the relationship is that RSCs are a subset of server-driven UI. And when you look at it as one big story and one holistic approach, then it all starts to make sense. And RSCs become a lot less scary for us React Native folks. And no one put it better but the man himself. RSC is a small part of the universal server-driven UI story. And I cannot wait for the talk that's happening, I think tomorrow, 2 days from now, about RSCs that Evan's going to do. Thank you all very much, and that's my Twitter and LinkedIn if you want to stay in touch.